All right, Assalamu alaikum everyone. Welcome to another lesson. This is going to be our second last video on the lesson number 4, which is nomenclature. So that's something you should be excited about, that this lesson is finally ending and we're going to be moving on to the real stuff. All right, so this video is specifically focused on ketones. Now if you're someone who is watching these videos for the very first time, you've not done the AS chemistry, then you need some practice in identifying the ketone group. So whenever you see a carbon and then you see this C double O group and then you see a carbon next to it as well on the other side as well, that is a ketone. So basically you have this thing right over here is known as the carbonyl group. All right, I'll mention it over here. You will eventually have to learn this, but this thing right here is called the carbonyl group. The C double O group is called the carbonyl group. And when you see next to this carbonyl group two carbons or two groups of carbons, we say that this is a ketone. So let's see in more depth how do we name these creatures. So as always, the rules are in front of you. I won't be going over them. We have gone over them like multiple times. So C is basically a ketone. Once you identify that, you know that the suffix is going to be unknown. So it's going to end with, after the root word prop, meth, eth, it's going to end with unknown. All right, so propanone or butanone and stuff like that. And in this case, just like in the case of carboxylic acids, because the functional group in itself has a carbon involved, we want to give that carbon the highest preference. Now, there's one important thing that I want you to note over here. The smallest possible ketone that you can make is going to be what? Just think for a second. You need 1, 2, and 3 carbons to make a ketone. So, what is going to be the smallest possible ketone? So, I hope your answer was propanone. And the reason for that is because you can't have ethanone, because in the case of ethanone, right, you just have one carbon on this side. What are you going to attach over here? Right, that's the question. You need to have a carbon, a carbonyl group, and then a carbon in order to make a ketone. So remember that the smallest possible ketone that you can make is propanone, because you need to have at least 3 carbons to make a ketone. Okay, now let's do examples and let's get this out of the way. So I can see 1, 2, and 3. So there are 3 carbons in the longest carbon chain, and so this is going to be prop. Now, what you're going to see is that you have this C double O group, and next to the C double O group, you have 2 carbon groups. And so I know this is a ketone, and so I'm going to name this as propanone. All right, not propane, propanone. All right. So this is going to be the name of the first case. All right, and this is because in this case as well, in the case of carboxylic acids, we saw this as well. We have to count this C, this carbon, which is part of the functional group, as part of the longest carbon chain. All right, because that's going to be the case for like all molecules which have carbons in their functional groups, and if that carbon is directly attached to the chain, it is definitely going to be counted in the longest carbon chain as well. And so whenever someone says propanone, you shouldn't just think it has 3 carbons उस functional group को छोड़ के नहीं. This means that this molecule has 3 carbons in its longest carbon chain. That is what it should speak to you when you hear a molecule's word like this. All right, name like this. Okay. All right, let's go to the second example. In this case, I see 1, 2, 3, 4, and 5 carbons. And so I'm going to name this as pent. And then what I see is a C double O bond. And next to it, I see groups of carbon, or 2 carbons are directly attached. And so I'm going to call this as pentanone. Okay. Now, similar. All right. Now, yeah. In this case, now here's the interesting bit. Now, if you note, in the case of carboxylic acid, the COOH group was a terminal group. It was always at the end, so it was always getting the number 1. But in this case, this is not always going to be the case, because look here. In this case, I can number this as 1, 2, 3, or I can number this as 1, 2, 3. Doesn't matter. the CO, see this, the the functional group in this case, or the C double or the carbonyl group in this case, is always going to be at number 2. So if you want, you can take propanone, and this is kind of similar to how we do it in alkenes and in alcohols. We add the number in between of the name. So if you want, you can do this. All right, you can say it's prop 2. All right, yeah, you can say it's prop to unknown. It's, I don't think, my bad, no, 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 it's not prop to unknown. It's going to be, let me fix that. It's going to be, come on, it's going to be prop to own. So for example, in alcohols, when we were doing butanol, for example, when we broke it, we kept the an over there, and then we brought the ol on the other side. Similarly, in the case of ketones, you keep the an on this side and you take the on the other side, and you break it apart and you put the number in the middle. So this is propane to on. All right, now the thing is that in this case the 2 is not necessary, because whatever numbering we do, it's still always going to be on the carbonyl group will always be on position 2. So it's not essential to do this. However, now when we're talking about pentanone, in this case the numbering is important. Why? Because how about this, name this molecule for me, and then we'll proceed. Name this one for me. You can pause the video and think about it before answering. So you can just name this molecule for me, this just one molecule which is in front of you. Now in this case, you'll notice that you have 1 2 3 4 5 carbons again, and you once again see a C double bond and a C and a C. So you can in fact name this as pentanone as well. So this means that this is pentanone and this is pentanone. So how are we going to differentiate between these two? Because remember how I said that the true name of a molecule is as such that when you read it, you should have an exact image of what you're talking about. So when you're saying pentanone, and you can have like two possibilities, this is vague, right? This is not very exact. And so this means that over here, the numbering is important. And so I can start numbering from here 1, 2, 3, and then 4, and then 5. And in this case, if I number it 1, 2, 3, 4, 5, and what you notice is that in this case, the carbonyl group is on position 3, and in this case, the carbonyl is on position 2. So there is a difference, right? And to indicate that difference, I'm going to break apart this molecule's name and add in the middle pentane 3-one. And this means that this 3 is indicating that our carbonyl group, or the C double group, is on position number 3, or is getting the number 3 as it's in its. All right, so I hope it is making sense that sometimes numbering becomes important in case of ketones, because in case of very very long carbon chain ketones, right, the C double O bond can be shifted here and there towards the right and the left, and it will result on different positions, and so the naming of the molecule will differ. And for that, what we do is that we mention it by explicitly writing it in the middle of the molecule, just like in the case of alkenes and in the case of alcohols. All right, now I'm gonna go on and talk about the fourth example. Now, all right, the third example. In this case, you can see I'll once again draw these out for you. So 1, 2, 3, 4, and 5 carbons. So this is going to be named as pent, all right? And then I see this C double O group over here, and then a carbon here and a carbon here. So this is going to be a ketone, so pentanone. See how this and this is the same thing, but there's a difference, because in this case, our C double O group is on the second position, whereas in this case it was on the third position. This was the one that I drew out a minute earlier. And so to give it its full name, I'm going to break apart the molecule's name and write down pentane 2-one, so that the person knows exactly where this carbonyl group is located in this longest carbon chain. Alright, now let's try out the fourth example. So 1 carbon, 2, 3, 4, 5 carbons. However, ask yourself, is this the longest carbon chain? No, it is not. It is this, right? Because this is the one that I can highlight without picking the pencil up from the paper. I can't do this, right? That's not right. So in this case, you can see you have four carbons, so it's bute, and then you can see that you have this C double O group involved, and so I'm gonna like mention this as butanone. And now, to you can ask yourself if you can actually shift the C double O group around, and perhaps you tell yourself, yeah, well, yes, I can. And if that's the answer, then it's best to also number this sequence in such a way that this carbonyl group gets the lowest possible number. In this case, it is getting 2. So I'll break apart the molecule's name. I'll break apart this molecule's name and mention in the middle that this thing right over here is butane 2-one, or sorry, not butane, it's butan 2-one. And then remember that there's still a methyl group located over here, so I have to mention that as well. And so I'll write down 3-methyl butane 2-one, butan 2-one. All right. So I hope, I'm hoping, like always, that this is getting clear to you, and it's making sense to you. And once again, the alkyl groups are considered much later once we're done naming the rest of the molecule. All right, the last example is a bit interesting because I've chosen it specifically because if you look at it, and if you look closely, you realize that this is a diketone. It has 2 ketone groups involved. Here's one of them, because this carbon is attached to this carbon, and it is also attached to this carbon. And then you have another carbon over here, which is we have this carbonyl group, which is again attached to a carbon and is also attached to a carbon over here. So this is in fact giving us these 2 ketone groups. So it's a diketone. Now the interesting part is, well, wait a minute, how do we name these diketone creatures? All right. Now, just like in alcohols, remember how we said diol, triol. Very similarly, we will also do the same case over here. And what I'm going to do is, let me first count the longest carbon chain. So that's always our rule number 1. So 1, 2, 3, 4, 5. So I can see that there are 5 carbons involved. So I can write pent. Now the interesting part is, well, how do I specifically tell where that there are 2 ketone groups and that there are where are they located? Okay, so just like in alcohols, what you do is you name I'll write these rules over here because I don't want to make a separate video on advanced ketones because they're not usually asked. So I'm going to put a star here. This is something which is not usually asked, but I'm putting it out there so that this gets clear in your head. The rule number 1 is you name the alkane part fully. All right, so you name the alkane part fully, and in this case it will be pentane. The second thing is that you use terms like dione or trione depending on how many ketone groups are there, because there are 2. So I'm gonna mention over here dione. So this is pentane, dione. And the third thing is numbers come before the name. Now although in alcohols we place the numbers in the middle over here, right, between the full name of the alkane and the diol or triol, and then in the middle we used to put in the numbers. In the case of ketones, we put it in the starting. So let me number this 1, 2, 3, 4, 5. So I can see the second carbon and the fourth carbon, they have this ketone group involved. So I'm gonna say this is 2, 4. Pentane, dione. Once again, this is not usually asked in your exams, these kind of names, but I want you to know it so that in case this does show up in your exam, you know how to solve it. So name the alkane part fully, all right, and then mention how many ketone groups are involved. Dione tells there are 2, and then you specifically give the position of these ketone groups, which is 2, 4, and then the dash, because we always separate the numbers in the alphabets with dashes. So that's it for today's lesson. I hope I didn't complicate things much for you. I'm trying to keep them as simple as possible. So if you like this video, give it a big thumbs up, subscribe to the channel, and hit the bell icon, and I will see you next time. Khuda Hafiz.